The new Raptor factory is now rising out of the ground as SpaceX's rocket development and test facility in McGregor, Texas. Tasked with supplying Raptor 2 engines to the Starship program, SpaceX is laying the foundations for its rapidly reusable rocket. With Booster 4 and Ship 20 reunited at the launch site, both vehicles will undergo proof testing and static fire tests before becoming an integrated stack for the second time. Unlike the earlier mate, which was for fit checks, and the next joining of the superheavy in Starship will be for the orbital velocity test flight. First, both Ship 20 and Booster 4 require proof testing ahead of a static fire campaign to ready the vehicles for flight. These objectives will be carried out amid continued work at the Orbital Launch Site (OLS), which is being prepared for Booster 4, Ship 20's flight and future missions that will include using the Mechazilla system. With the launch tower in the process of gaining its Mechazilla stacking and catching arms, a key part of recovering Super Heavy and Starships along with their engines, numerous future vehicles are being staged at the production site ahead of a busy 2022. The immediate focus is on Ship 20 with its static fire test currently scheduled soon. Following a successful proof testing campaign for Ship 20, the next milestone will be loading LOX liquid oxygen and CH4 liquid methane for a static fire test. The fine details of Ship 20's testing have not been revealed, with this vehicle being the first to sport 3 Raptor vacuum RVAC engines. To date, RVACs have only been fired up individually at McGregor. The upcoming test, currently set for no earlier than NET Wednesday and still subject to change, will likely involve the 3 sea-level Raptors. Ship 20's full engine set involves RC-69, RC-73, and RC-78, with RC standing for Raptor Center. RV-4, RV-5, and RV-6 are the RVACs assigned to Ship 20. During the initial static fire test, one key test objective will focus on the Thermal Protection System (TPS), which suffered a minor liberation caused by the header tank venting. The vibrations of the engine's firing will provide additional data points on how well the TPS has been applied and secured to the vehicle. Booster 4 is waiting in line for its proof testing and static fires, although this is likely to occur this November. With its 29 engines, Booster 4's static fire campaign will likely involve several ignitions, with an increasing number of engines. The Super Heavy was removed from its orbital launch site (OLS) mount to allow for the installation of Mechazilla hardware to the launch tower. Mechazilla. Progress towards giving the launch tower its arms has been made over recent days, with the carriage system moved over to a new staging point at the orbital launch site (OLS). This set the scene for the lift and move of the first chopstick arm for installation onto the carriage. Once both arms are secured to the carriage, the entire system will be hoisted onto the tower. This event will set the stage for its first operation, likely to involve Booster 4 being lifted onto the mount. These giant arms will be used for raising and stacking by the Super Heavy Starship system, and eventually catching the duo during the return to the launch site. This, as per Elon Musk's recent tweet, could come as soon as Booster 5's return. With the structural framework of the Quick Disconnect QD arm already installed, the chopsticks for Mechazilla are said to be the last major addition to the tower. The QD and chopsticks make up the total of the Mechazilla system, given the QD arm also provides stability to the stack during mating options. A giant claw-like carriage structure has also been observed, which provides some insight into Mechazilla's design. However, the confirmed setup will only be known once all the elements have been installed. Should the system require additional work, the LR-11350 crane, nicknamed Frank Crane by SpaceX employees, could still be used. While Booster 4 and Ship 20's return points will be into the ocean, Elon Musk hopes for the first catch to occur during Booster 5's return to the launch site. Another element which is being fabricated at the production site is another attachment for the QD arm. As per the setup of the launch tower, the ships will be supplied with propellants and other needed commodities via the QD arm high on the tower, while the Super Heavy boosters will be fueled via the QD plate located on the launch mount. The other key element for the OLS's readiness is the tank farm, tasked with satisfying the thirsty needs of the world's largest launch vehicle. Numerous rollouts from the production side of the launch site have involved new ground support equipment, GSE tanks, and their cryoshells, the latter used to insulate the GSE tanks as they are filled with supercold propellants ahead of supplying the vehicle. To this end, SpaceX finds itself in several tandem processing flows, focusing mostly on Ship 20's upcoming orbital velocity test. Currently awaiting its restacking with Booster 4 to become an integrated stack once more, workers have been busy replacing thermal protection system (TPS) tiles on the nose cone area of the vehicle. This process has seen technicians replace several hundred tiles, detonated by the various colored stickers placed on the areas of interest. While the specifics of the color coding are not known, this does mirror the previous days of processing flows of shuttle orbiters inside their OPF, Orbiter Processing Facility, where the vehicle's TPS was maintained. However, the main difference between Shuttle and Starship is the pace of replacements, with Ship 20s taking days. Such a large-scale replacement took many months for the shuttle orbiters, as evidenced by similar TPS tile berthing issues with Shuttle Columbia in 1979. Once the TPS tiles work has been completed, Ship 20 can look forward to proof testing, which normally begins before the installation of Raptor engines. Future vehicles. Interestingly, while the focus remains on Booster 4 and Ship 20, the build-up for Booster 5 is already picking up pace. In recent days, the next super heavy sections have been spotted in the usual staging areas outside of the production tents as a preamble to stacking operations. Booster 5 is already being stacked inside the high bay, following the usual Starbase path of having the next vehicle ready to head to the launch site soon after the previous has launched. Its grid fins have already arrived and are being prepared for installation. This process took place after the booster completed stacking operations during Booster 4's high bay processing flow. While numerous sections are without labels, one that did sport its identity was Booster 5's aft section. Positioned in the usual spot where sleeving takes place, Booster 5 stacking operations are set to begin imminently, with the common dome section for the next super heavy already moved inside the high bay, with the other sections lined up in the production site yard. Amazingly, the first section with the Booster 6 label has also been spotted, with NSF's Nick Ansuini catching the common dome section at the production site. While the high bay is ready to support the next Starship duo, the mid bay has hosted the final GSE tank, GSE 8, ahead of its rollout. Ship 21 will now be stacked in the mid bay before rolling to the high bay for nose cone installation. Although Starship production cadence has been one of the standout highlights of the early years for SpaceX's Starbase, future production requirements require even more capacity. As confirmed by Elon Musk, additional capacity will come via an even larger high bay, which in typical SpaceX fashion has already begun construction to the north of an existing high bay. Ship 21 is making good progress around the production area, with sections being prepared for stacking, a process that will take place inside the since vacated mid-bay. The rollout of GSE 8 to the tank farm has created room for Ship 21 stacking to occur. With numerous sections sporting a full coat of TPS, the nose cone for Ship 21 is already following that same path. With tiles being applied inside one of the big tents, sections for Ship 22 have also been observed, with the common dome section spotted inside Tent 1. Meanwhile, the thrust pucks for boosters down the pecking order have also been arriving into Starbase, including the first to host the expanded capability of 33 Raptors. McGregor Factory. All these Raptor engines arrive at Starbase after having been processed at SpaceX's McGregor test site. Currently, the engines are assembled at SpaceX HQ in Hawthorne, California, before taking a road trip to Texas for hot fire testing on one of the 5 available test stands. Elon Musk has already noted that Raptor production would increase, aided by a new factory at the McGregor facility, allowing Hawthorne to focus on RVACs and new design evolutions for the Methalox powerhouse. This allows McGregor to produce the main stock of Raptor 2 engines to cater for a large number of boosters and Starships, each requiring 36 Raptor 2s in total, based on the 33 on the booster and 3 on the Starship. With the groundwork observed by Gary Blair over recent weeks, the latest pass noted the framework of the factory is now being assembled. While this factory will still be some time away from assembling Raptor 2s, Hawthorne is already building the streamlined version of the Raptor, with the McGregor test stands being worked on in preparation for test firings. Centralizing Raptor production and testing at McGregor will also streamline the flow of Raptors to Starbase, removing the California to Texas leg for all engines except for the RVACs. Also, this production increase provided a fascinating scenario of how many Raptors SpaceX will require in circulation. Given the full reusability of the Starship system, a large stock of Raptors points to a huge fleet of vehicles, as Musk has always envisioned. What do you think about these new Raptor engines? Let us know in the comments section below. Thanks.